sort of in the way.
Yeah.
Yeah. Why is YouTube breaking so much lately?
I know, dude, it's tripping me out.
Also, I'm thinking I've got a good topic to talk about.
Alright.
And I was thinking of talking about maps.
Right.
Because, you know, you've got a whole lot of stuff going on with it. And there's a few things that I'd actually like to... When it comes to maps, I think the best evidence for the globe is to do with maps, so...
Yeah. Absolutely, me too. What did you want to talk about specifically?
Like the sort of things that I was thinking of talking about. So I'm going to start off with something that's kind of different, but that's just sort of before it goes up and everything. I'm just going to turn my camera on for a second to see if I can just make sure that it works.
Alright.
On here. Because I know that it has trouble when I'm... Yeah, it's gonna have trouble, isn't it? Yeah. Okay. I'm not gonna be able to use my video camera, but...
That's alright.
I mean, people on the stream will see me.
Yeah.
And if I really need to, I can just deactivate the camera on the stream to show you. If I need to demonstrate something in real life, I can just deactivate the camera on the stream and use my own.
Okay.
Use it on Hangouts. Alright. Okay. Alright. I'm just going to do a sound check first.
Can everybody hear me?
Oh, this is recording, so just say something.
What's up, everybody? What's up, YouTube?
Okay, and now I'm just going to play that back, make sure it's all good. This PC. Video this. Oh wait, that's wrong. Oh, okay. It was stored in a different format, FLV. Have you used OBS before?
No, I don't even have a computer.
Okay. I do recommend getting a computer for live streams.
Yeah. I got a laptop, that's it. I can't hear you no more.
Okay, I'm gonna.
Oh, there you are.
I'm gonna have to turn your volume up, I think, or turn mine down.
Yeah, yours is pretty loud.
Yeah, I might just turn my volume down a bit. Wait, I need to... Do I have a... Oh, I have a compressor. That's why... That's why it's... Yeah, I'll just chuck the compressor off and... Okay, now I'll just do another record test.
Alright, what up, YouTube?
And... Oh, geez, it's... Now that I've taken the compressor off, my volume seems to be way down.
No, I can hear you.
I'm meaning on my end.
Oh.
Yeah, properties. I filters. I'm going to have to turn the compressor back up. Well, turn it to negative 15 dB. Okay, let me just another test recording.
What up, YouTube? What's everybody doing tonight?
Okay. Okay, I really need to work out. Maybe if I turn this down to what was it there before? Okay, hopefully this is it.
Alright.
Let's see,
Testing, 1, 2, 3.
okay, I'll just drop myself down by a couple of dBs and we should be good.
Alright, awesome.
Negative 2, there we go. Okay. Okay, we should be good. I'm just going to close Unreal because I don't need that hogging up. Processing power. Just check my. Here we go. Task Manager. CPU. 30. Okay, that seems good. It's way down at 16% CPU, so. Okay. And yeah, the intro's good. Alright, so what I'll do is I'll just mute us both, start the stream up and just plug it in some places and then we'll be good to go.
Alright.
Start streaming. I haven't actually streamed a debate yet, so this will be interesting.
Yeah. And then last time we talked was the first time I did it.
Yeah. Because I've done live streaming before, it's just,
Oh.
hasn't been,
In debate form.
yeah, because I've been live streaming games.
Yeah.
That's fun.
Alright. Yeah. Same as Planarwalk. Yep. When you live stream, it should just plug it automatically to YouTube.
I'm plugging it
Oh, okay.
You should join Discord, it's pretty good.
Yeah. I got an account, but I just erased it. Yeah. So what were you saying? What were you saying about maps?
I'm gonna just turn up audio on first. So I'm just gonna start it up by saying a few things.
Alright.
Ahoy hoy, I'm Planarwalk. Welcome to a stream with me and Flat Out Hero. Today we're mostly going to be talking about maps, but there's a few things that I'd like to say first, so let me just get everything sorted and go to correct scene. There we go.
Ahoy, ahoy.
That's usually what I say as an intro. One thing that I'd like to say is, because I was watching your last stream that you did, and one thing that I do have that I can speak to you about is that, because I know a lot of flat earthers that use the Bible as justification for the flat earth, and to me it doesn't make much sense.
Not at all.
I'm just going to call Gustavo. Hopefully there's more people that come and watch it, but I have posted it on Discord and everything, so yeah, I do respect that you haven't decided to go, because honestly the Bible is just, it's brutal.
Yeah. For real. Yeah. The Bible doesn't earn respect even if you read it.
I should walk in and say, though.
So Sean.
But anyway, today I was thinking we could talk about maps, because one of the things that I always get confused about is the flat earth model, and because I understand the globe model perfectly fine, but the flat earth model is very hard to argue against when there's nothing that's really solidly defined. And I think that to have something solidly defined is a good thing, but if it's not solidly defined, then it becomes very weak as an argument. So I'd like to say, I'd like to ask, is there any particular maps that you think is the true map of the true shape of the Earth?
Absolutely, but the only problem is I don't know if anybody has put them all together yet. But if you take such maps like the Thomas guides or flight charts that take small areas of Earth and they do a topography of it, and then you have place them together like puzzle pieces, and then if we were to set those all together, that would be a map of the world. But as far as us needing a model, we don't need a model. We're not, what flat earth isn't to claim that the earth is flat, or to it's not about anything about us claiming what shape the earth is or what's happening. All it is about is saying that this is how heliocentricity is wrong. Even if we have no idea how anything else works, like that's not anything to do with what flat earth is all about. Flat earth is pointing out that it's not round. It's a lot flatter than what they've been telling us. And there's a reason why they haven't been telling us the truth.
You see, my response to that would be that it's a good idea is to come up with a model, right, that describes reality accurately.
In time when we're allowed to, yes, but we're not allowed to go certain places, so we can't give you that model.
Gustavo has been saying, Planarwalk, please answer, what is this all about? And I'm just like having debates, and and that's and discussing things with people, because even if I don't change your mind, there might be people watching that want to know what my thoughts are on certain things. And
absolutely.
So anyway, back to what we were saying is move in the way that they do, why the sun moves in the way that it does.
No.
I think it does.
Alright, but I mean the way that it explains it, everything's moving at different miles per hour, and we see the same stars that we've seen for 2,000 years doing the same thing that they've always done. Flat earthers, long before anybody heliocentrics, of that opinion, they mapped the stars. Like, the stars have been mapped before. We can't even read the languages, but we know what the pictures mean. Like they mapped the stars a long time ago, and those same stars are still going right above us. They're circling above us. They're not traveling out from the Big Bang, from original position. Everything flying away like the Earth, 67,000 miles through, 67,000 miles an hour through space. Like, there's a lot that doesn't make sense about it at all.
Well, I think that first off, you got to look at some of the things, because you claim that we don't see that we don't see stars moving. That's actually we do see stars moving.
I never said we don't see stars moving. Of course we see stars moving.
Well, we see stars. What I'm meaning is over periods of times, right? We do see.
Oh yeah, no, we should be seeing different stars all the time. If we were expanding from one central point in outer space where everything was just Big Bang, everything's going away from it, we shouldn't have any stars circling above us ever. They should be traveling with us and going the direction that they're going from the Big Bang. For them to be circling above us, especially on both the northern and southern hemisphere, that's ridiculous.
Well, we actually do see the stars move in relation to each other. Like we've predicted.
Planets, we do, yeah.
In the future, I think Orion will look completely different. I'm not sure how long it's going to take before it looks completely different. And another thing to mention is that.
So if you can't see it, how are you going to say that we see it?
Well, we have measured. This particular star in Orion compared to this particular star have moved compared to how they were maybe 50 years ago, right?
Well,
so we can then.
The only wandering stars are called planets.
Well, planets they move from year to year, and we can see they've moved a lot during this. Actually, they move from day to day, but we can measure. They are quite clearly moving, but when it comes to other stars, we need a longer time frame to look at them to see how far they've actually moved.
Yeah.
And so we actually have worked out, yes, they are moving, and they're all moving in a predictable way. It's not as if.
But they're not moving away from us. They're not moving away from a central point. Like the Big Bang claims that everything expands from a central point. There's a Big Bang and then boom, everything is flying away from it at insane amounts of fucking speeds. But that is not what we observe in the night sky or in reality by any means. Like, there's no way.
One of the things you do have to note is that the galaxies are receding away from us, and the reason why we can measure this is due to redshift. Now, the stars in the sky that we see are stars within our own galaxy, and because they're orbiting around the center of the galaxy, that's why we don't see them racing away from us.
They're not orbiting away from us. They're not orbiting around the center of the galaxy. They're expanding away from it. That's what the theory says. That's what the Big Bang Theory says, is everything is expanding away from a central point in the universe. Not orbiting it at all.
Well, here's the thing. It's expanding. The galaxies themselves, right, are expanding from a point in the universe. We don't know where that point is because the universe is so big. But the stars in our galaxy, our galaxy is moving away from some point in the universe. Where that is, we don't know exactly where it is, and our stars in the galaxy are moving around the galaxy due to gravity. It's orbiting around the galaxy. It's not.
The entire galaxy should be expanding away.
What was that?
the entire galaxy should be expanding away from the Big Bang. Everything should be expanding away from the Big Bang.
Yeah, like the galaxy is expanding away, or moving away, it would be a better way to put it. All the other galaxies are moving away, and when it comes to what we see, the stars, they are moving around the galaxy because of gravity. Does that make sense?
Not at all, but okay.
Yeah, and the people in the chat have made the point that if you look at the stars over a period of a few thousand years, they will change. It's about the time frame that you
Well, they should be changing nightly. They're expanding at different speeds than us, and we're talking like insane amounts of speed. So the way that they've got it set up is we should be seeing different stars nightly.
Not really.
Dude, yeah, there's thousands of miles of different, thousands of mile an hour difference, dude. If there's thousands of mile an hour differences, think about that. Like we would not be able to see it if it was traveling that much different speed than us. That's thousands of miles per hour.
Let's take, I'm going to just Google something, speed of the solar system, right?
Mm-hmm.
And that is 828 kilometers per hour, right?
The solar system?
Yeah.
Well, Earth alone is traveling 67,000 miles an hour supposedly.
Well, our solar system is moving at 828 kilometers per hour, right? So let's work out
how is it moving slower than Earth?
What?
How is it moving slower than Earth?
That's 230 kilometers per second.
Yeah, it equals out to like 67,000 miles per hour. No. Speed of Earth away from the Big Bang.
That's just like through the
Through the
because this
universe.
isn't taking into account the speed that the galaxy's moving. So this is how fast we're moving in the solar system. Because it's down to relativity, especially when it comes to the stars that we see. Right. So.
Okay. So the whole galaxy is moving, and while it's moving 67,000 miles an hour. That's the thing. The Earth is moving 67,000 miles per hour, but the Sun is moving like something else. It's moving in different speed, and then all the planets and the stars are moving different speeds. Like if they're all moving different speeds, how are they staying in the same galaxy? How are they staying?
So the reason for this is because when we measure these speeds, we don't actually measure them in relation we measure them in relation to whatever it is that we are saying. So when I say that I'm driving at 200 kilometers per hour, right? I'm not measuring that in relation to the sun. I'm not measuring that in relation to the galaxy. I'm measuring that in relation to the Earth. Because in relation to the Earth, I am going at 200 kilometers per hour, right?
Yeah.
Well, not right now. I'm going at 0 kilometers per hour. But if I'm driving a car and it says it's 200 kilometers per hour, that's in relation to the Earth. However, the Earth in relation to the Sun is traveling at 67,000 miles an hour, right?
Yeah, the Sun is moving faster, I think.
And the Sun is moving at 828 kilometers per hour in relation to the galaxy, and the galaxy is moving at, I think it's about 2 million miles per hour in relation to everything else.
So the galaxy should be we should be passed up by the galaxy long ago.
Well, we are ahead of the galaxy by the gravitational pull. Because, yes, we are travelling at the same speed as the galaxy. We just don't, when we say in relation to the sun, we don't account for the Earth's speed through the we don't account for the Earth's speed through the universe as a whole. Because we've got to have some sort of thing that we relate it to.
Alright.
Anyway, I'm just grabbing this here. Oh, yeah. How far are these days like? Oh, jeez. That's...
Google it.
9.5 trillion kilometers. Okay. So, now let me bring up my calculator because I am not willing to math that much in my head. So, 9.5, actually, clear that.
But what does this have to do with maps, though?
Huh?
What does this have to do with maps, though?
I was just explaining because you said how the stars, we shouldn't see the stars. Things do wander, like
Yeah.
conversations.
No, I know, but what we were talking about maps. Like I wanted to know what you wanted to know about maps. I was interested in your question about maps. Because you're right, that is a big deal in my channel right now.
Yeah. So, are there any? Whilst I'm doing this, because I kind of have this on my mind right now, I just want to finish up this point.
All right.
Okay, so I've got here 9.5 trillion kilometers. Let's divide that by 828,000 kilometers. So that's hours. So it would take for us to get to the nearest to get a light year away. A light year away is quite a lot. 24. So that would be 400,000 days to get caught away to the closest star at the current speed that we're traveling, right? Which is 365, which is 1,000 years. So, approximately 4,000 years, we could, traveling at the speed that we're traveling, we could get to the closest star, right? And that's, 1,000 years is a long time. That's why we don't see all the stars changing. Because, as I said, to get to the closest star, it would take 1,000 years. And that's why we don't see every star changing from night to night. Not to mention that that's just that's the closest star that I'm talking about is 1,000 years.
Well, there's no way to verify. There's no way to verify that math is right, though, because it's all just that's what they say it is,
I mean, I don't know the maths behind it, but I could talk to someone that.
It's not about the math. It's about their numbers, their figures, what they say it is. They say that it's millions of miles away or whatever. Then there's no way to verify it. It can't pass a scientific method. It can't be repeatable experimentation that can prove that that's true. So it's just theory that we're going off of. Yeah, that's what they think. It's what their theory is. It's what their math came out to. But that's just because they're basing it on a globe,
Well, the thing is, we do have other supporting evidence, and this is what we'll get back to now, because with the globe, as I said, at least for me, it may not be the case for you, but it provides a sound reason of why things work. It provides. The model gives a reason for eclipses. It gives a reason for why the sun moves in the way that it does. It gives a reason for.
But it doesn't explain why we don't see the moon in the sky when it's supposed to be covering the sun. How we only see a shadow cover the sun, and it doesn't explain why the moon and the sun have been in the sky many times when the eclipse happens. So it proves that it's not the moon covering the sun, and it's not the sun, it's not the earth covering the moon. Like there's certain things, there's a lot of discrepancies that you just don't know about because they didn't teach you in history, but there's plenty of evidence to say that it is not the moon covering the sun and it is not the earth covering the moon.
Well, I think that when it comes to the solar eclipse, as I haven't actually seen any actual evidence of the moon being in the sky at the same time as an eclipse, except for the shadow of the moon, and we wouldn't expect to actually see the face of the moon during an eclipse beside that
no,
moon that we see.
But we would expect to not see it that night when we do see it, because the sky in the daytime, how in the hell did it just jump all the way back around and then come and do it at night? The moon is a nighttime orbiting object. It is not a daytime orbiting object. There's no way that it can be at 10 or 11 o'clock in the morning in the sky and then cover the sun and then come back and be there for the nighttime too. It doesn't do that. It comes once in 24 hours, not twice.
Well, I do see the moon during the day sometimes.
Yeah, for a little bit in the afternoon, not at 11 in the morning.
But, it's... as I said, I don't know, I haven't seen any evidence of it appearing on the same night as an eclipse, right?
Well, it has to.
It doesn't have to.
Yeah, it has to stay, the moon has to stay in a lunar orbit, a nighttime orbit, in order for it to, it doesn't ever leave a lunar orbit. Yeah, like it can be visible during, the winter or whatever, when the days get shorter. It's not going to be anywhere near its zenith as what they want you to believe that that's what happens during the eclipse. I just watched the last eclipse of the sun almost. That's when they want us to believe that just for that one day, that one specific little day, that the moon jumped its orbit and transformed its orbit for so dramatic that its zenith was during 11 o'clock in the morning, and then it was perfectly fine that night and every other night. Like, come on, man.
Well, the thing is with the moon is that, or with the thing with the solar eclipse, it always falls on a new moon, right?
Alright.
But
it's not every new moon that it happens.
No, it's not every new moon that it happens.
Yeah.
But it always does fall on a new moon.
Alright.
And so we know that I've never seen someone see a new moon in the high in the sky at its zenith during
11 in the morning.
11 in the morning. Well, I mean, would it be?
You've never seen that? No, nobody's seen that. That doesn't happen.
Oh, we see crescent moons, but
Not at 11 in the morning. Never.
I have seen just trying to think. Crescent moons. Let me Google moon phases. I'm not sure.
At no point in any of the moon phases do they come at 11 in the morning.
Well, it would do during a. For crescents, it is possible to come during 11 in the morning, but it would be a very small crescent.
Okay.
Or it could be a new moon, and at that time you don't actually see the moon. What you see.
How often does a moon zenith come at 11 in the morning? Have you ever seen a moon? No one's ever seen a moon at 11 in the morning.
It would be about it's like the same thing. How often do we see the full moon zenith at 12 o'clock?
Where are you getting that answer from?
Well, it's to do with it's to do with how often we see it at its zenith at any given time. If we want to say how often do we see it at and it would actually be a little more than once a month. But when I say once a month, I mean.
Are you Googling it, or are you coming up with that, bro? Because I'd really be more interested in what Google says about that, because I know for a fact I've never seen the moon zenith at 11 in the morning.
Well, it's a combination of using the model and using logic. So
yeah, that's what I'm saying. Like logically, yeah, that's what you gotta have. That's what you gotta think. But now, like, if you Google how often is the moon zenith at 11 in the morning, see what the answer is.
Okay. How often is a moon zenith at 11 a.m.?
Yeah.
Okay, it's not giving me any results here. But we can go to Wikipedia, and if I just go to and hello Flathouse and all the people that are in the chat. So if I go to here and just go here. Application window. Let's go this one here. Right, so for each lunar phase, right?
Mm-hmm.
It gives a. Actually, I'm just gonna click onto here. There we go. So for each.
It gives a corresponding time to each phase of the moon.
Yeah, so it has the average moonrise time and average moonset time, right?
Mm-hmm.
And I'm pretty sure the mid-phase standard time is when it's at its zenith, right? So
no, the zenith is when it's at its zenith.
It doesn't say zenith here. It just
well, in between the middle, in between when it rises and sets, then the middle.
Like mid-phase standard time would be its zenith, pretty much.
Okay.
So for a new moon, right? We see that it is, we can't see it during its zenith most of the time. If it's slightly off a new moon, okay, then we can see it, and that's why we get eclipses at usually around midday. So all the information is here. And waxing crescent, we see it at its mid-phase at 3 p.m. As it gets smaller and smaller, it'll be closer to midday that would see it at its zenith. That makes sense.
So 6 p.m. is I'm trying to see. Okay, so midnight would be half.
Well, if it's at its zenith at midnight, it would be a full moon.
Okay. You're saying that you just can't see it. It's at zenith, but you just can't see it.
Yes, most of the time you can't see it. If it's if there's a small part of it that you can see, then you'd be able to see it at its zenith at times closer to midday.
Mm-hmm. Okay.
So
That's
as a
not.
general rule of thumb, I think it's safe to say that we see as a general rule of thumb, the more of the moon that you can see, the closer to midnight that you'd see it. The less of the moon you see, the closer to middays you see it.
Right.
When I say close to midday, I mean it's see it at zenith point, closer to midday. Same with you'd see it if it was a full moon, you'd see it at zenith closer to midnight.
Alright. So, yeah, it's convenient that you just can't see it, but, you know, whatever. If they want to say so, that's fine, because that's not really, not a flat earth proof or anything. It's just, that's, the eclipses are, nobody really knows what's going on with the eclipses, you know what I'm saying? Like, they're explained to be something that we've seen both the moon and the sun in the sky at the same time, so there's no way that it could be the moon, you know? It's been historically documented. So.
Well, I haven't, honestly, I haven't seen this happen, but, you know, if you
I
want
haven't
to,
either, yeah.
if you bring up proof for it, then, you know, I might be able to.
Yeah, I'll look into it. I'll look into it for a later discussion. I'll try to find out the names and people who've put it down. But, alright, well then here, how about this? Going back to maps, like, I do have, an issue going on my channel about maps. Everybody's trying to say that, Woofy plotted his flight chart, or plotted his flight course on flight charts. It's just that they're electronic. Well then, no, he didn't plot his flight course on flight charts. What he did was he plotted his flight course on a computer, and then on a computer program, and expected me to just accept that because that is where he charted his flight. That's not how it works. The whole the proof is that we know that Thomas guides regular flight charts. Wolfie knows what a flight chart is. He's just trying to weasel his way around it. Regular flight charts are sheets of paper that are printed out with a real small section of Earth mapped out, and they say that they don't need to use or account for any curvature because it's such a small area. Well, the challenge is if those are accurate depictions of Earth in small pieces, then they're accurate when you put them together to form a big picture. If the big picture forms a flat Earth, and you can still navigate by it perfectly fine, and you can't make that triangular flight course on it, then Earth is flat. Like, there's just no other going. There's no denying that. Like, do you have a way that you can justify that?
Well, the reason why we use these flight charts for small areas is because, and yes, when you have a small area, like say from Dunedin to Christchurch in New Zealand, right? You'd use you could get away with using a flat flight chart because there's not much curvature that you need to account for, and nothing really gets distorted. But if you want to make a flight from just say Australia to New Delhi, then you need to use more of a globe chart, and that's why they've got these in planes. They've got computers that do this because it's very hard to plot a globe on a flat sheet of paper.
It's impossible.
And so, I mean, if you were to get all these flight charts, and MC Toon has been making great progress on this, get all these flight charts and map things out, you would find that they don't quite, unless you plot it to a globe, they don't quite match up, because for every map that I've seen, there's every flat map that I've seen, it's distorted in some way.
No, like they say it's distorted, but it's not the distortion. The globe is the distortion. If you'll notice, did you watch Wolfie's response to where he said that he plotted the flight course? Did you actually look at what the flight course was?
I did look at the flight course.
Did you notice how it forms a circle?
What do you mean?
His triangle on a ball forms a circle. What that flight course is a circle. It's not a triangle. His lines are bent. When he zooms out and and it's showing the ball, because he plotted it on a ball, which is against the rules. But but when he zooms out and it shows it, it's a circle. Like that's what he's flying. And yeah, you can fly in a circle and get back to where you're going. Yes, but you can't do it in straight lines. And what they're asking, and what they're is you have to fly in a circular path due to the curvature of the Earth. But your airplane is above the Earth at all times. You're never having to climb above. You're never having to go around a huge mountain. So there's no reason to curve your path. You should be able to fly a straight line because you're always above the Earth.
Well, if I'm on a globe, right, and I travel 10,000 kilometers in any particular direction, right?
Mm-hmm.
I'll form if I'm traveling one particular direction. Now, to me, it's like I'm traveling in one direction, right? But if I actually look at how far I've traveled and all that sort of stuff, it'll actually form a quarter circle.
That's what I'm saying. Like, no, it doesn't though. Like, if you really walk in a straight line, you are walking in a straight line.
But if I walk in a straight line for 10,000 kilometers, that will form a quarter circle because of even though to me it feels like a straight line
Mm.
to the to Earth, it's in relation to Earth, right?
Mm.
And I'm not sure even using in relation to Earth but in relation to me and the ground, it's a straight line, right?
Yeah.
However, in relation to anything beyond Earth would see me travel in a quarter circle.
Yeah, if that's what Earth looked like, but we know from when we put a camera up and as far as we can go, as high as we can go into space, any amateur, if anybody that's not associated with the space program puts a rocket into space and they put a regular, not a GoPro, not a fisheye lens, it's not a skateboard video, if they put a regular lens camera up on that thing, it does not show any curvature whatsoever. And NASA's been showing us curvature from 30,000 feet forever because they've been using fisheye lenses.
I mean, I have seen a few amateur rockets being sent up pretty high,
Mm-hmm.
and they do show curvature.
No, not unless you're using a fisheye lens. Ones that aren't using fisheye lens, then there's no curvature whatsoever.
There's some people that have put a rocket into space, well, not into space, but
No,
have
yeah.
gone pretty high up with a 360 degrees camera,
Mm-hmm.
right? And they actually had to sort of
The,
take a
the,
small
the,
chunk of it to make it look as though it had no curvature. But if you watch the 360 video, then the curvature is visible. You also see people
that's
that
because they're using a fisheye lens. That's what those cameras are. Is a 3D fisheye lens. It's a wide view camera. That's why you're getting that. If you use a regular lens camera, like you know what you see with your own eyes, and if you take just like my camera right now, what I'm viewing, it is a regular lens camera. I see what it sees. I know that that's what it looks like. So when that camera goes high into the air and shows us that there's no curve, I know that if my eyes were right there with that camera, it's showing the same thing because I just saw looking through it on the ground the same thing that I'm seeing through it. It's not a distortion. The fisheye lens is the distortion. When you send one of these cameras, if you would send your phone up in the air, dude, without a fisheye lens app, it's gonna show no curvature all the way to the dome, or whatever it is, whatever stops it.
how about these people that have gone on a plane,
I've been
and
on planes.
they've taken video and stuff of because when you're on a plane, you've obviously got the clouds in the way. So a lot of the time when you're on a plane, you can't see the horizon, right?
Sometimes, yeah.
Or you can't see the true horizon. You see the horizon of the clouds, which is it's a lot higher, so you can't see any curve.
Okay.
But there are people that have gone in a plane and gone up high enough and had a relatively clear day where they could see curve.
Even the guy who did the highest jump, the jump from the Red Bull thing. If you look on his video, he stayed number one. He stayed right above New Mexico. He didn't rotate. The Earth didn't rotate anywhere underneath him or anything. So that was kind of funny. But he when he's jumping out of his little hot air balloon thing, his little chassis that took him up there. He's got a regular lens camera that shows him as he jumps. So it's showing all these curves. It's showing all these fisheye lens from outside. They've got fisheye lens on the outside of that thing. And then for the only shot where it shows that one camera where it shows him just jumping out, it's a completely flat horizon right out the door. Like there's no curve whatsoever.
Well, we wouldn't see the. You wouldn't, like, a lot of times it is how much you see. Like if you see a small section, then you're not going to see any.
It's not a small section though. Like you can see that would be. You should be able to see a whole bunch of curve. Everywhere else shows a whole bunch of curve. It's just that it's not a fisheye lens camera, so it's showing it as it is, as you would see it, as your eyes see.
But we don't even need to go to that because there are other ones which show that that show the curve, right?
Not without a fisheye. Show me one that shows me a curve without the fisheye.
Give me a few seconds. I'll just bring it up.
Yeah.
Because
Yeah, you got a cigarette? You want to smoke a cigarette? Almost. Let's cigarette.
I'm just going to get this tab here. And hello, Sasha, and everyone in the chat. I'm not going to explain what you missed because that would take a while. Site. Okay. This might be it. Screen share.
Alright.
So this is from Greater Sapien, right? He does a lot of good demonstrations, so
You say so.
I think that his content is good for. I think his content is good for reference material. So in this picture, you can clearly see that there's a curve there, right?
Wait, you saying? Yeah, I can. That's not a regular view camera.
So first off, if it were a
Show it on the show it at the very beginning of their thing, and show it so it we can see it on the ground. And we'll see what it looks like. And see if it's got the same curve as it does on the ground. You see how it's got the same curve on the ground as it does in the air?
Not really.
Yeah, it's got a curve to it. You know that's not what you see when you look out at a driveway or a parking lot. Dude, that's a curve right there. That's a fisheye. Watch, play it. Watch how the curve will always be there on the edges.
I'm just going to open up GIMP, or actually no, Paint. And Gustavo, I believe that the Earth is round. So I'm just... Alright, so let me screen share Paint instead because I can...
Hell yeah, Emperor.
Okay, here's a it's annoying having all these different windows.
Yeah. Oh,
Okay,
we lost you.
Yeah. Windows. Paint. Okay. So with this, I'm going to take a line and just go from here, and you know.
See how it's curved at the edges?
Not really.
Look at the mountains, man. The mountains are above that line.
Yeah, that's what you'd expect to see because the mountains are, you know.
Well, look at the horizon line too. Look how it curves down, and just watch as it plays. If you play the video, it'll show it.
Well, the horizon line isn't curved so that you can properly see it, but this is a straight line here which follows the horizon.
Watch, play the video. It'll show it. Is it not playing?
Oh damn! I just realized something. Hold up. I was sharing the wrong screen.
Oh.
I'm telling you, I need to work out my screen sharing properly. Stop screen share. Screen share and go to this one. There we go.
That's the same one.
Yeah. Actually, I need to open up this. Yeah, I'm telling you, having a lot of windows is annoying. So
yeah.
Here we go.
See how it bubbles down? As it goes above and below the middle of the screen, it goes up and down. That's what fisheyes will do. They'll concave and then they'll bow out.
But generally, you see it being rounded towards like if something were top of
it's a fisheye is what the thing is. If it wasn't a fisheye, it wouldn't be rounded at all. Like if it's a fisheye lens, that's what I'm saying. You're gonna get curvature because the lens is curved, bro. If you just look at type in non-fisheye lens high altitude air balloon, and you will have that's exactly what you're looking for because that's not a fisheye lens.
Okay, so I think this is the lowest it goes in there. So let me take this into paint. And I'll just
why go through all that? Why not just Google? Why not YouTube a non-fisheye lens camera being sent up in a high altitude? Because it'll show you a non-fisheye.
Well, I was showing that this is. I'm just trying to show that this is not fisheye because if I take a line here.
Well, we know what non-fisheye looks like. That's what I'm trying to show you. Like you don't have to guess or do paint or anything like that. Like there's non-fisheye lens cameras that have been sent up there, and it'll show you there's no curve whatsoever as high as it goes.
Like even here, this is taken from when it's when the horizon is below the bottom of the screen. There isn't a.
It's barely below it. It's really close. It's really close to the middle of it. If it's farther away from the middle of it, that's where it gets the most bowing.
Well, this is at the same point. Like if I grab more of the screen, for example, like if I go Control Shift S and just more of the screen here, and screen sharing paint? Oh, it is. I'm sharing my whole window. So yeah. So if I take this here, right, and then I take a line, go from one side of it to the other, line from here to here, it matches the horizon. I can even.
It's a thick ass line. It's not your line's pretty. No, it doesn't. There's on the left side. There's gap.
could be because of the mountains.
No, on the left side there's gaps. There's gaps underneath the line. Like that's the horizon. The horizon dips down because that's where the the rest of it is level. Isn't that part too? It's a fisheye, dog. Like that's what those cameras do, dog. Like you can type in non-fisheye right now and you don't have to do any of that.
But it matches. You gotta.
It doesn't match. It does not. Like it's a fisheye.
It matches.
It's
pretty closely.
It's a fisheye. It's beyond. It's beside the point whether it matches closely or not. I want to see what it really looks like. I don't want to see it. It's not a skateboard video. There's no reason. It doesn't matter if it does. Even if it matches perfectly almost. Like, I want to see it perfectly. Not perfectly, almost. I want to see it perfectly.
Well, if you have something that's perfect, you know, in statistics it's down to something like.
It is a curve. It makes a curve, dude. That's what fisheye lens does. It makes it curve. Like, just type in non-fisheye, and then you don't have a problem with it.
Okay. Non-fisheye.
High altitude balloon.
Let's me. One of the things that was good for, because you could clearly see that there was a bulge that couldn't be there in the other. You know, if you're not going to accept that, then there's this one here. Because this one actually, this one is a fisheye lens. You know. This is clearly a fisheye lens.
There's different fisheyes don't just have one. There's like really severe fisheyes, and then there's not so severe fisheyes.
Well, this is actually more severe fisheye than Greater Sapiens.
Why are we looking at fisheye? I don't want to see a fisheye. I'm saying show me a regular lens, not a fisheye at all. If you show a fisheye at all, that ruins the whole thing. You're supposed to be looking for what you see.
Yeah. But that one just before, like, I went onto it and it was definitely fisheye. You could tell that it was some fisheye.
Mm-hmm.
Hopefully it's not fisheye.
I've got a good one on my playlist if you can't find them.
It's hard to tell whether this one's fisheye or not, but you know.
Well, they say it's not, so I mean you'll be able to tell when it goes by the horizon, because there's no camera that does the opposite effect of fisheye. There's no camera that can make a curve flat. There's only fisheye that can make flat curves.
Well, you can make a curve flat using fisheye. It just depends where on the fisheye it is.
Yeah, but it's exactly. It's not going to be. It's going to be it'll be a fluctuating thing. You'll be able to tell because it fluctuates as the camera rolls.
This one here doesn't look like it's fisheye, but
no. And that's what you see all the way up.
I just realized something.
What's that?
Shit. Oh, that's why. Hold on. I just realized that I'm seeing what I'm seeing here. That should be better.
Mm-hmm.
There we go. Let me just bring up. This one, yeah, looks to be like it is, like the horizon's flat. But the thing is, with the last one, or with Greater Sapiens one, should I say?
Mm-hmm.
You know, that one, there's clear curvature, right?
So how is there curvature
we
from
have-
an airplane when this is 120,000 feet and high? This is way higher than an airplane. So how are they showing curvature if it's not a fisheye lens from a smaller altitude?
Because with the Greater Sapiens one, if I just go back to this one here, you can see in this one here that the horizon is more defined.
Yeah, except for it's closer to Earth.
Yeah, so it's much clearer when you go.
Wait, hold on. When you go further up, it should be way more detailed. Like you should see a lot more curvature the higher you go.
Not well.
Yes.
When it comes to detail, like this one is pretty clear. You can see that. You can definitely see where the horizon is.
He's using a fisheye lens, bro. Like, yeah, if you were to have it, as that non-fisheye went up at that height, it was still flat. No matter what, it was flat the whole way up.
Oh, the thing is, like as I showed, it's pretty. When it comes to Greater Sapiens video, right?
Mm-hmm.
You know, I showed that this here is pretty.
It's a fisheye.
Close.
It's a small fisheye. Yeah.
It's when I brought up paint, it shows that
there's gaps on the left side.
But it's not enough to be, you know, if I try and draw a line on anything, you know, my line's not going to be perfect.
There's no. If you have a non-fisheye lens, it's perfectly straight. Yes.
But with like if I brought up paint, like there's a few things I want to bring up with this. Where is it? Where it is? Okay. Now screen sharing. Stop.
And my iPad's about to die too, buddy. So.
Okay. Application window. And the curve. I know. Paint. Where is paint? There we go. All right. So here we've got the. So the first thing to note about any fisheye is it tends to. You tend to get a distortion, a bit like this, right? So things below the center would distort, above the center would distort that way. We can agree on that, right?
Yep.
Okay. So the first thing that you've got to note is that this is below the center of the screen. So if it were distorting due to fisheye, we'd see something that would be like that.
If it was an extreme fisheye, he's not using an extreme fisheye. He's using a very low fisheye.
But would still expect it to distort this way rather than that way, right? When it's below the.
It doesn't matter at all, man. He's showing a curve. If he's showing a curve at all, in the air or on the ground or ever, you know it's a fisheye because the regular lens camera does not show any curve the whole way up. So if we're arguing about something that's completely beside the point, man. We know what a regular lens camera shows. Like, this is not what a regular camera shows. So to argue whether or not it's just a little bit due to the curve of the camera, no. Like, and to say especially that it's lower when it's lower that it's going to show more curve than when it's higher, just because you can see the horizon more clearly, that's not anywhere near what we should observe.
Well, when it's lower, it will show. The horizon will be more clearly defined, as in.
No, it should be curve. If there's a curve, it shows more curve the higher you go. That's what historically the NASA has shown us. That's what everybody has believed will happen. That is what if you do a computer program, when you rise above a ball, that's what happens. When you rise above a flat Earth, this is what happens. It rises with you.
Well, take for example, if I now this is going to be happening on the stream. I'm just going to my webcam properties, and I'm just going to go configure video, right? What's going to happen here is I'm going to go out of focus, right? Now that I'm out of focus, you know, I could bring up something that's ever so slightly curved. Let me just find something that has a slight curve to it. Like this. So now that I'm out of focus, we've got this thing that's ever so slightly. I'm just trying to lessen the curve of it. So it's ever so slightly curved, but you can't tell that there's as much of a curve on it as there would be because it's very blurry. As you go high up, the horizon is not as defined as, and I'll just...
when you see the horizon from the same height that Greater Sapien is showing curvature through a non-fisheye lens, it does not show that curvature. It has the same detail on the horizon. It has everything the same except for there's no curvature. So we're arguing a moot point.
Well, no, I don't want to save my changes. Look at the reflection of the glass in the pane window. He's shooting with an iPhone.
Mm-hmm.
And yeah, I'm pretty sure the iPhone cameras aren't fisheye.
They have a slight fisheye to them, yes. Look at the camera. Look at the camera's lens. If you don't believe me, it's bulged out. It's a fisheye lens, dude. Every lens, as a matter of fact, has a small amount of fisheye to it. They're all like that. It's just how dramatic the curve is. Like the ones that are non-fisheye lens are the closest that we have to actual what we see. Even those have a small little curve to them because that's just how lenses are made.
Yeah, I do agree that every thing has a slight fisheye to it, but in this one, it's not.
Did you hit this?
It's not.
You want me to make a dab for you?
It's not enough to give a noticeable effect.
No, I got it.
Now, if I go to the
Are you done with this?
tell you, I've far too many windows open.
Oh shit.
Oh, I can just...
Hey, Planarwalk, bro. My iPad's about to die right now, but I'm gonna have to sign off.
Okay.
Yeah.
Before you go, I'll just show that if I go later on in the video,
Mm-hmm.
where he's, why isn't it showing at the right time? Okay, so when it's in the center of the screen, there should barely be any, and whenever anything's in the center of a fisheye screen, there should be pretty much no fisheye. Unless there is extreme fisheye on the camera, you should see no, there should be no fisheye, unless you've got extreme fisheye lens.
Or if he's using, or I mean, I'm sure that they've got an app for it. You know, you could probably make it fisheye too now.
But you know, there's multiple results to see. You know, I honestly would like to see this kind of thing for myself by going up higher than aircraft. But
yeah, well, I mean, you can just stand a camera.
But if you say that this is just fake, this is just fisheye, then you've also got to call into question the validity of things that say that they aren't fake.
Well, yeah, but I know that the only reason I'm calling it fake is because I know what non-fisheye looks like, and that's not what it is. That's what fisheye looks like. So
to To me, it doesn't look like fisheye from what I.
It doesn't.
What I
It
can
doesn't. Have you seen it through a non-fish eye? Because you just looked at it from higher up from a non-fish eye, and there wasn't anywhere near that much curve. And from higher up, it should be way more dramatic.
But in this one, the horizon is
right there. It's flat. But yeah, I got my iPad's about to die. Yeah, it died. Alright, guys, later live stream. Sorry I wasn't answering anybody in the box today. I was letting him do his this time. Next time I'll answer questions from the box. Everybody have a good night. Stay